TV channel. I'm Sulakshana Wagmare and today I'm going to take Science of 7th Standard from MSB, that is Maharashtra State Board. Today we will learn about the sound chapter, which is related to sound, and name of the chapter is Propagation of Sound. This is your 11th chapter. So as you have already learned about the vibration of source is necessary for the production of sound. In the last chapter, you must remember, in order to have sound, the particle must vibrate to produce the sound. Now what is required for the propagation of sound? That we will learn today. In order to propagate the sound, propagation of sound means the sound will travel from one place to another. If it don't, we will not hear any kind of sound. Now when an object begins to vibrate, the layer of air in contact with it also begins to vibrate with the same frequency as that of the object. As a result, the layer of air next to that layer also begins to vibrate. Thus, the sound travels away from the source. Now, I will explain you this. If suppose I have some source, it is producing sound. Because of that sound, the particles of air which are nearer to source will also start to vibrate with the same frequency as that of the source of sound. So, because of this vibration, the particles next to that particle will also start to vibrate. This will continue and particles in ascending or descending order will start to vibrate, and this way sound will travel from one point to the next, from next to next to that, and so on. So in this way sound travels from one place to another place. So the substance through which sound travels is called the medium. Now here air is one medium through which the sound was traveling. So here we see that the medium is necessary for traveling of the sound. Now to prove this, let us try this experiment. You must done this in your childhood. So let us see what is the experiment. You have to try this at home if you didn't. Take 25 meter to 30 meter length cotton string. Now fix each of the string to one center of the base of an empty paper cup that you can see at your home. We just give rasna or cold drink through that cup. So you have to take that cup. Now take two cups and tie the string in between them. So that picture you can see here. Here one such a experimental setup is made here. Now this is your telephone. Now tell your friend to hold one cup to his ear and pull the string straight and taut. Means the thread should be straight. There should not be any breakdown in between them. So hold other cup to your mouth and speak into it very softly, and you will see that your friend can listen this voice. Though the voice is soft, then also your friend can listen this voice. Now why this happens and how does this happen? The paper cup, when you speak, start to vibrate. Means suppose I am holding that paper cup and I am speaking. Because of my sound, that paper cup will get vibrated, and these vibrations travel through the string and reach to another paper cup which is holding your friend. So that paper cup, another paper cup will also start vibrating, and that sound will be heard by your friend. So if you wish to hear better than this, you can use wet string, that means wet into the water. So your voice will be now heard more clearly in this case. So this experiment shows that we can hear the sound from one place to another place, and here the medium which was transferring the sound was the string. So if the string breaks and you knot it, means string is broken and you knot it, and repeat the experiment, you will see that you can't hear the sound. That means because of vibrations are not transferred in this case. So because of that you will not hear any sound. So also sound needs string or some other medium for its propagation. Means this experiment shows that there must be medium in order to travel the sound. So in the first case that I explained, that was air which was transporting the sound. In this experiment, now string is a medium which is transporting the sound. Now to verify medium is necessary for this propagation of sound, we will perform one more experiment. The experimental setup is as this, you can see in the figure. We will take one conical flask. Now take a round bottom flask with some water in it. Now take two holded rubber stripper that you can see, means there is one rubber stripper having two openings, so that's why it is two holded. Now take two holded rubber stopper, pass a glass rod or wire through one hole that you can see in the figure. There is one glass rod and one wire. Now tie a bell to one end of the rod and fit the stopper to the flask with the bell inside the flask that you can see. Now pass a glass rod, means pass a glass tube through the other hole and attach a piece of rubber tubing to its outer end. Now fit it with a clamp and close it. Now shake the flask, means you have to take the flask and shake it. Now here you will listen the sound of the bells which are ringing. Now open the clamp and heat the flask till water boils and steam come out of through the rubber tube. Means you will boil the flask, water which is inside the flask will get converted into steam, it will pass away. Now stop heating the flask and clamp the rubber tube shut. Means we will apply the stopper and the knot that we will tie, which is attached to rubber here, so that air can't enter the flask, or if there is air inside the flask, it will not pass away. So now allow the flask to cool, let it cool, because initially we heated it, so let it cool. If you pour water from outer surface, it will get cooled earlier. So now steam, what happens because of cooling? The steam which is inside the flask, as you know, it is hot due to heating. So when we pour water from outside, the steam cools and condenses. That means it will get converted into water. So now shake the flask again. You cannot hear the ringing anymore. Why? Because after the steam condenses, that means it gets converted into water, there is no medium left inside it to carry the sound out of the flask. So now open the clamp and shake the flask. You will hear the bell quite clearly because the outer air has now entered the flask and it acts as medium again. So thus it is clear that medium is necessary for the propagation of sound. So this was the experiment, simple experiment. If air is there, you can hear the ringing of bell. If air is not there, you can't listen any ringing because there is no medium for the propagation of sound. Now from these two experiments, we can write the conclusions as, my first conclusion will be a medium is necessary for the propagation of sound. Second conclusion will be sound can be propagated through solid, liquid as well as gaseous mediums. Means sound can travel through solid, liquids and gases. Third conclusion will be sound travels faster through liquid than a gaseous medium and fastest through a solid medium. That means sound will be fastest in solid, then faster through liquids and fast from the gases. Means sound can travel with the fastest speed through the solids. Now to verify this third conclusion, again we will perform some experiments. Now the next experiment is very simple. You must done this. Now let us see what is your experiment. Now ask your friend to knock on a table with his finger or a pencil so softly that you can you can barely hear the knocking. Means without putting your ear on table you can't hear that. But now put your ear and you can just scratch the table also, or your friend can scratch the table also. You will see that you can hear that. Now this particular phenomenon you must have performed in school when there is off period and you are playing or just putting your hands on benches and all. So what you will see, you will find that you can hear the knocking at the other end. Means your friend is knocking at one end and your ear is at other end. So you can hear that. So you can also perceive that sound comes through the table. So this experiment shows that this table is transferring the sound. Let us perform another experiment. This is also very simple experiment. You must have performed this in your childhood. Blow a balloon and hold it close to your ear. Listen to the sound you make as you scratch on the balloon. Now let the air pass out the balloon and fill it with water. Means instead of air, now we are filling the balloon with water. Now scratch it again. What is difference do you notice in the sound? You will see that sound is more clear and can be heard clearly through the water than through the air. So this experiment shows us that sound can travel faster through water than through air. So these two was the experiment. Now the next topic is reflection of sound. Now, have you ever been visited to a hill station? If yes, you are almost certain to find echo point there. If you shout standing on the top of a mountain, the sound is reflected back from the mountain opposite to you and you will hear the same shout again and again after some time. This is called echo. This tells us that sound is reflected from a flat surface and travels back in the direction from where it came. So this was the reflection of sound. Now what is reflection? If you didn't visit, means if you didn't visited any hill station, you can perform this experiment to hear the echo, that is reflection of sound, in your home or in laboratory of your school. Now in this particular experiment, here you can see the experimental setup. I will explain you. Take a long about 10 cm wide wooden plank that you can see in the figure. Place it across a table as shown in the figure with its width perpendicular to the surface of a table. On one side of this piece of wood, lay a plastic tube of 2 cm diameter on the table at an angle of about 30 degrees with the wood. At the end of the tube, place a watch that makes a tick-tick sound. Place a similar plastic tube on the other side of the piece of wood. Take a point at which the two tubes meet. Stand a flat, smooth piece of wood at right angles to the long plank. Means this will be the perpendicular in this particular experiment. Now suppose the plank to be normal at the point. Now put your ear to the outer end of the second tube and listen for the ticking of the clock. Vary the angles, means for that particular watch we will vary the angle. Now if you vary the angle, this tube makes with the long piece of wood till you hear the ticking clearly. Means angles with variation of angle, the sound volume of sound will be variable. Means for a particular point the sound will be softer, for a particular point it will get a little louder, and for one point it will be much clear. So now repeat this experiment changing the angles first tube every time. Now what do you see? When the two plastic tubes make equal angles with the piece of wood between them, the ticking can be heard most clearly. Means one side watch is there, one side you are keeping your air. Now move that particular plates. You will find that for a similar angle that making with the plank, the sound is much more clear. So from this experiment, we again draw conclusions here. My first conclusion will be sound is reflected from a flat surface, since we are keeping flat surface in front of that plank. So sound is reflected from flat surface. It will not reflect from opaque or different shaped surface. And second conclusion will be, when sound is reflected, the direction of the incident sound and the direction of the reflection makes the same angle with the normal. That I mentioned already, means we had the clear sound at similar angles. So this was the second conclusion. Now our next concept is speed of sound. As you know, everything or every particular object which travels have some speed. Now sound is also traveling from a source to at a particular point. So we will find here the speed of the sound. Now you have seen that speed of the sound is greater in solid than in liquid than in gases. So what is the speed of sound? As a temperature of 20 degree Celsius, the speed of the sound in air is about 340 meters per second. That is, at 20 degree room temperature, our sound will travel 340 meters for a second. It increases as temperature increases. We cannot compare the speed of sound with that of light, since the light travels at about 3 into 10 raised to 8 meter per second. That means on 3 we have to put 8 zeros. That means for that particular meter, light will travel in a second. So you can see light has much more speed than the sound. So we can't compare those two. That is, light travels speed which is of the order of 10 raised to 6 times more than that of the sound.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. Make sure your mustache hasn't started coming. Choose the right study time and forget games, IPL, IHL, rock and metal, guitar, X. The right group, and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger. The night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
Since the speed of sound is very lesser than that of light, that's why you will now understand why when there is a thunder and lightning, we see flash of lightning first, but we hear the sound later. So this is example, the sound travels lesser with the speed of light. So here one more example you have. In the festival of Diwali, you burn rocket. We see light of rocket first and then we hear the sound of boom. So this shows the sound have lesser speed than that of light. Now we have our next concept. It is the concept of musical instrument. Now you may have attended a music concert. What are the instruments played by those accompanying a singer? String instruments have several strings. The strings are plucked to produce sound. Each string has a different frequency. The desired frequency can be obtained by adjusting tension in the string. You must have seen the guitar player adjust the string by tightening the knobs at different places. So they adjust the frequency of the wire, the frequency of the string. Now in percussion, instruments like drums are stretched membrane is struck to produce the sound. You must have played with drums, or you have some instruments in your school also that are used to produce the music or sound. The tension in the membrane can be varied. You must have seen the drum which have knob around its circle. They are adjusted to have a tension in that particular stretched membrane. So according to that, sound is produced. Now hence, the desired frequency can be obtained by adjusting those particular knobs. Now in wind instruments, sound is produced by blowing air into them to cause vibration in a column of air. Means suppose we have a pipe, in that you have a flute, in that air column is there. Now air is blown inside, so that air column inside that flute start vibrating and we hear a sound. Now by placing fingers on different holes, the length of the vibrating column of air can be varied. Means that air column will start vibrating with different lengths, hence produce the sound of different frequencies. So thus sound of the desired frequency can be obtained. Now we will learn the new topic, noise and the music. As you know, the sound we hear, we can categorize them into noise and a music. So what is basic difference between noise and music? To see this, we will do one experiment here. Now sir, place some pebbles in a tin and shake the can. Means you will take one can and put some pebbles inside and start shaking it. You hear sound. However, there is no regularity in this particular sound. It is irregular. Hence, we perceive it as a harsh sound. What is the difference between sound of traffic, crowds, etc. on the one hand, and the notes of the flute when played on an accompanied artist? Means we are comparing those examples which are producing noise and one example which is producing a beautiful music. So the basic difference that we can compare here between the music and noise by these examples. The notes from flute are in a particular rhythm. Means one after another sound is produced in a particular order. Their frequencies are in harmony. Harmony means all the sound or all the frequencies of sounds are coordinated by each other. That's why they produce a beautiful music. The sound has a specific regularity, hence the music has a melodious tunes. In comparison, noise follows no rules. Frequencies change constantly, loudness changes irregularly. So that's why it is harsh to hear. Now when everyone in class speaks together, nothing can be understood. There is only noise. So that is also the difference between music and noise. So lastly, we will mention that music is that kind of sound in which there is regularity between the frequencies and loudness. But in the noise, there is no regularity and loudness is also varied. So we can't understand anything from it.